So now in this exercise, we're testing the difference between two means-dependent samples. How do you guys know if the samples are dependent? If you see a table with 3 columns or 3 rows with names in the first row or the first column, and then before and after, you know these are dependent samples, and you have to test it in a different way. He says a fitness trainer wants to determine if the new exercise program improves strength. A random sample of 9 participants recorded 9 or 8. Let me see. I only have 8 here. It is 8. 8 participants. So just change the 9 to 8. Recorded the weights they lifted in pounds before and after a 6-week program. So here's the first thing that you have to do, guys, is do the difference before minus after. 100 minus 110, 120 minus 130. Now, you need to test the average of the difference, whether it is a positive or whether it is negative, whether it is not equal to 0. Here's how you figure it out. Let's take the first participant. The weight this person lifted before the training, the new exercise program, was 100. After the exercise program is 110. Ask yourself, did he improve? The answer is yes. Keep the yes in mind here. What's 100 minus 110, which is negative 10, and this person improved. If the difference is negative, then you want to test, just that the difference is negative. If he didn't improve, let's say it was 100, and then after it was 90, that's not what we're aiming for. So you look for the difference. So T is negative 10.583. That's your step number 2. P-value is 0, which is less than alpha, so you reject HO, and your conclusion should be that there is enough evidence at the 5% level of significance to support the claim that the new exercise program improves strength. How would you do this one using the calculator? To use your calculator, first of all, you have to input the data into L1. Let me show you how to do that, and then we can perform the test. So you input the data into L1 just like I did, and make sure to use this for the negative sign right here. And then you go to stat, you go to tests, t-test. You see how popular this t-test is. Enter. And now data. We're testing against 0. Remember, when the samples are dependent, we're testing against 0 always. And what do we need to test? Less than 0. And hit calculate. Same thing, guys, as you notice what we got from StatCrunch, negative 10.583. But I want to bring something to your attention. Look at the p-value here. It says 7.3539 E minus 6. The E minus 6 means you have to move this decimal point 6 digits to the left. So it's going to be 0.000007, which is almost 0, which is less than alpha. And then you get the same conclusion that there is enough evidence at the 5% level of significance to support the claim that the new exercise program improved the strength.